For the second presentation, I would like to follow the first. So we can give several exact examples. What is the real effect, the different renal infrastructure, for example, the road bridges to one taxonomic roofs, conservation capacity, or invasive monitoring programs to native crayfish, non-native and native crayfishes. Quite interesting is the situation that time in Hungary to the road network. When we talk about that time, the road network density of the Hungary, this is the 5 biggest density road network system in European countries. After the Benelux countries and Czech Republic come the Hungary. After, when we would like to create the plans 2030, we would like the second position after Dutch countries. So it's interesting when we would like to create that time all a road, when you travel one bicycle road, railway line or normal roads, 1.5 kilometers you will cross one natural aquatic habitat system. So running water or standing water habitat you will be crossed. The plans, after the plans, 0.6 kilometers you will cross one aquatic habitat structure. And we have no exact information what could be the real effect, this very dense network system of our country. But it could be quite interesting question, all right, about, we can talk about that amphibians, reptiles, and so large mammals, ungulates, large carnivores. Why we would like to focus on crayfishes? So the crayfish is one of the very, very important keystone species in aquatic habitat structure, umbrella species too. This is one of the big, quite interesting ecological engineer species in aquatic habitat structure in the world, not in the European, but in the North American continent aquatic habitat structure too. And quite interesting the situation to see which habitat structure use the native species and which prefer well and use as stepping stones the invasive species when they start colonizing new aquatic habitats. Monitoring program, quite interesting. We used the Water Framework Directive and Natura 2000 monitoring system. We have different guidelines as in the other European countries. Basic information, we start in the CDR Harmony Project 2013. After the Transgreen, Connect Green, and Safe Green, we use these methods, and several local action plans we can create it with several NGOs in the whole territory of Hungary. So the biggest program, we monitored 138 different type of road bridges in whole territory of Hungary, and each situation we monitor in one section 3 different, in one area 3 different sections, an upper section, bridge cross section, and down section. And quite interesting situation that after the results we can analyze the monitoring system that, for example, the noble crayfish and narrow crayfish population less the habitat more than 95%. So absolutely destroy 2 very important crayfish species, which was earlier used as very, very important industrial species. But up to date, these species are separated different small areas, so cross the connection between a lot of population. But up to date, what is the new results based on this monitoring program? More that, as previous presentation, I can talk about 23 new decapod species we can detect it in the Hungarian waters. And you can see a parallel that the stone crayfish, we can measure only 3 different small populations, small area in whole territory of Hungary. But parallel, we can see that the different type of bridges and channel system spread the non-native crayfishes well parallel with the river Danube. But the other problem comes from Austria, the signal crayfish. This spread extremely fast in the whole drainage system with sourcing area come from Austria, Slovenia, and Croatia. The Rabca river system colonized twice, and the extreme density we can find where are repreps between the dams or under the dams. And the other situation, the west area of west drainage area of Lake Balaton, where the signal crayfish, not signal crayfish, sorry, marbled crayfish start colonize extremely fast the road cross sections in the different channel. channelized habitat structure. And the other part, quite interesting, in North Hungarian mountain area, where several natural thermal springs used as sourcing zones of non-native species, but the man-made created urbanized structure as the bridge cross-section used as stepping stones to spread these shrimps and other crayfish taxons in this area. So it's quite interesting to see the differences. So environmental parameter analysis, we can talk about that. We can separate it exactly well based on the environmental parameters, the bridge cross-section and upper and lower section. All right, but what are the differences between the taxonomical data sets? You can see that the numbers of non-natives, the exact individual numbers of native species are lower the bridge cross-sections, but it is significant, it is very, very important. But you can see the diagram B, where the non-native crayfish taxon individuals, you can see that upper section and bridge cross-section, you cannot find significant differences. So these taxons could be used, not only the bridge cross-section, but the ripreps, the other industrial elements which created the authorities as stepping stones and could be used as spread habitat well. So, and you can see previously the first diagram with the environmental parameters could be separated well, the upper, lower section and the bridge cross section. But after the analyze the species composition, you cannot exact separate it, that bridge cross section is different from the upper and lower sections. So it's quite interesting to see. And each situation have a lot of exceptions. For example, noble crayfishes in several small habitat where the most population was absolutely destroyed in the agriculture and urbanized dominated habitats. For example, in small streams in hilly area, we can collect these species only in the bridge cross section. Why? Because the environmental parameters which prefer these taxons could be used or could be measured only in the bridge cross section. The water velocity is higher, the sediment compartment is different as in upper and lower section. And it's interesting that we monitor several years long the Koppány stream in Somogy County, which is one of the most agriculture dominated area in the south area of Lake Balaton. And each season we can collect the noble crayfish only under the bridge cross section, not in the upper section, not in the lower section. And it's an interesting question in nature conservation perspective, that what could be help to connect this small separated population, because the upper section until Koppány T bridges, the differences between the bridges could be maximum 3 or 5 kilometers. So one huge flood could be connect these habitats or could help to spread these taxons. But in Nagykonyi and the upper section where the estuary area are dominated, so it is absolutely lawless populations. So discussion, we can talk about that all species have an oval spread dynamic in the Carpathian basins for non-native crayfish species, and different type of bridges have different effect of the nature conservation perfected native taxons. For example, we can see, I cannot present the diagrams, that from stone crayfish, which are well separated small habitat in the hilly area, it's well preferred the bridge cross section area when the harvesting in the forest area is starting, because the sediment transport start extremely fast in the hilly area. After that, the current velocity, the sediment compartment structure, you can measure and you can find only in the bridge cross section, because the sediment start to collect in the upper and lower section. So this habitat absolutely destroy in extreme harvesting periods. So back to the first slides, we cannot separate exactly blue, green and gray infrastructure. And this is quite interesting what is all results in crayfish species, but I hope in the next TNA conference I can present it, what is the situation with amphibians, reptiles, and other aquatic macroinvertebrate taxons, us and hope in us, in our name of our department, as with the fish taxons, because it is quite interesting, and the differences and similarities could be well interesting all experts. Thank you very much.